Okay, here we go. We're going to solve sine x equals negative 1/2. Our restricted domain is between 0 and 3 pi. So that means when we're looking at the unit circle, we're going to be looking for the place on the unit circle where the sine of x is negative 1/2. Sine of x is telling us to look for the y-coordinate. And so negative 1/2 will be in these two positions on the unit circle. Okay, so what we're going to do here, this is one of the simple questions because it just has, we're thinking about sine theta equals negative 1/2. And we can find that place on the unit circle here and here. So therefore we'll know that theta is 7 pi over 6 and also 11 pi over 6. When we do these kinds of questions, we're going to connect those two different answers by that violin-shaped bracket. And you'll see why in a moment. Okay, so for this simple question, we are actually, this initial equation is almost exactly like what we're thinking about for the unit circle because x is just in the place of theta. So in this case, we can just think about that unit circle within this restricted domain. And we can see that, okay, that first place would be a spot, so 7 pi over 6. This place over here would also be a spot, 11 pi over 6. And then if we go as far as 3 pi, that would only be to here. So there's no more solutions than that. So those are just the two solutions. So for example, 9a, we just have two solutions, which we can get directly from the unit circle, 7 pi over 6 and 11 pi over 6. Okay, now, when we get a tiny bit more complicated, we're going to do number B now. So very similar, almost exactly the same train of thought. We're still thinking about this idea of sine theta equals negative 1/2. Where on the unit circle does that happen? In these two positions. Okay, but now we're not just looking at sine theta. We're looking at, another color here, we're looking at sine 2x instead of sine theta. So our theta is now a 2x. So then when we start solving, we're not just going to say theta equals, we're going to say, or x equals, we're going to say 2x equals. And it's those same two positions, 7 pi over 6 and 11 pi over 6. So we're going to put them like this. Join them with that violin bracket. Okay, now this will happen, let's think about the periodicity here. That's going to happen every time we go around the unit circle, 2 pi more, 2 pi more, 2 pi more for 7 pi over 6. Also for 11 pi over 6, we go around 2 pi more, 2 pi more, 2 pi more. Or if we went back in the other direction, subtracting 2 pi. So because the period of a sine function is 2 pi, we're going to say plus 2k pi here. And that means we know that not only is it this solution, but every possible 2 pi around the unit circle, forward and backwards. Okay. Now, we talked about the fact that this is not just theta or not just x, it's 2x. Now we need to use normal algebra. How do we get x by itself? We divide by 2. So to get x by itself, we're going to divide both sides of these equations by 2. When we do that, this is what happens. And I'm going to need more space here. These take up a lot of space, these solutions. So I'm going to grab another board and keep on going. All right, so move that up a little bit. Our next step then, when we divide 7 pi over 6 by 2, we can think of it like this. 7 pi over 6 divided by 2 is the same as divided by 2, so multiplying by 1/2 instead. So multiply by the reciprocal here, so 1/2. So that's going to be 7 pi over 12. Okay, so our next step is x equals 7 pi over 12 now. And we also need to divide the 2k pi by 2. So that will be k pi now. Oops, don't need a line there. The same thing will happen with the 11 pi over 6. That will now become 11 pi over 12 plus k pi. All right, so here's the key part of this. We're now going to think about adding pi over and over and over. Just like in the previous example, we kept thinking about, okay, if we go around the unit circle, are we going to get more solutions or not within the restricted domain? So we're still dealing with this restricted domain, 0 to 3 pi, as stated in the question. And we're looking at 7 pi over 12 plus k pi now, because we had to divide by 2, and 11 pi over 12 plus k pi. These are not special places on the unit circle, but we can add pi over and over, or we could subtract pi over and over. So this is what we're going to think about. Starting with that first solution, 7 pi over 12. If we add pi, which is what this part's telling us to do, plus k pi, or if we subtract pi, what are we going to get as an additional solution? So 7 pi over 12, pi is the same as 12 pi over 12. Just looking for an equivalent fraction because as we add, we need a common denominator. So we're going to keep on adding 12 pi over 12. So the next one would be 19 pi over 12. Next one again, add 12 pi over 12 again. 19, 20, 31 pi over 12. And so on, keep on going. The next one would be 43 pi over 12. I'll stop there for now. If we subtract pi, we're going to have negative 5 pi over 12. All right, so now we have to think about how many of these solutions are within that restricted domain. Remember, our restricted domain was 0 to 3 pi. All right, so restricted domain 0 to 3 pi, which means our denominator's 12. So let's think about 3 pi as being 36 pi over 12, because that's equivalent to 3 pi. All right, so that means then that this is too big. 43 pi over 12 is too big. All right, 31 pi over 12 is good. 19 pi over 12 is good. 7 pi over 12 is good. Negative 5 pi over 12, is it within our domain? Well, we're starting at 0, so no, that one's too small. So from this one answer, 7 pi over 12, we actually get 3 answers that are good within that restricted domain. We're going to do that same thing with 11 pi over 12. So start with 11 pi over 12, add and subtract pi over and over again until we are beyond our restricted domain. If we subtract, we'll have negative pi over 12. Well, our smallest value we can have is 0, so that's too small. Add 12 pi over 12. Sorry, I might have said something wrong here. We start with 11 pi over 12. We're subtracting pi, which is 12 pi over 12. So we would get this, it's too small. Okay, add 12 pi over 12, we'll have 23 pi over 12. That's still within our domain. Next one would be 35 pi over 12. That's still within our domain. Next one would be 47 pi over 12. That one's too big because it's bigger than 36 pi over 12. So these are 3 more solutions that are good solutions for that restricted domain. So our final step is to write all of the answers. We've got 6 answers here. They should be written in order from smallest to largest. So we'll do that. 7 pi over 12, 11 pi over 12, 19 pi over 12, 23 pi over 12, 31 pi over 12, and 35 pi over 12. So 6 solutions there, and that's the end of that question.